Video is on solving exponential and logarithmic equations. There are two types of exponential equations that we'll solve. One where we can rewrite one of the terms or both terms with common bases, and one where you cannot do that and you solve by logging both sides. So the first one, number one, solve 5 to the 3x minus 1 equals 125. Okay, so when I solve this, I need to write 125 as the power of 5. So I know that 5 to the third is 125. I can either use a factor tree or divide by 5. And then I would divide 3 times. I could divide till I get to 1. When the bases are the same, the exponents have to be equal. So we now have 3x minus 1 equals 3. Add 1 to both sides. 3x equals 4. Divide by 3. X is equal to 4/3. If you recall, for our exponential functions, the domain is all real numbers. So our answers can be fractions, positives, or negatives. Okay, number 2, solve 1/4 is equal to 8 to the x. We want to rewrite 4 and 8 as a power of 2. So 4 is 2 squared, 8 is 2 to the cube. 2 to the third power. Now you have to be careful because it has to have the same base. So 1/2 and 2 are not the same base, but I can write 2 to the negative 2 using exponent rules is 2 to the 3x. Again, your bases are the same. Exponents are equal. And you get negative 2/3 is equal to x. Then if we want to check it, we can go ahead and substitute it in on our graphing calculator. And I plugged it in for x. I got 0.25. And I can convert it to a fraction of 1/4. So most of the time we can't do this. We cannot make or rewrite the exponents to have common bases. So for example, on number 3, 3 and 7/100 cannot be written as a common base. So we're going to log both sides. So because the base of the variable exponent is a 3, we're going to log base 3 both sides. Now, the reason we're doing that is so that our rule allows us to say that if your base of the log and the base of the exponent are the same, the exponent is your answer. Okay. Then you're going to divide by negative 0.02. And so we come up with x is equal to log of base 3, 0.07. And this can be negative, okay, because we don't like negatives in the denominator, divided by 0.02. Okay, that's an exact answer. And the approximate answer would be negative. We can use change of base, or if you have the 84 alpha window, and I get 121.028. And it rounds, usually they ask you to round the number to either 2 or 3 decimal places. Okay, so again, the first one is the exact answer, which is generally what mathematicians want. Okay, now here on number 4, we have to subtract 4 from both sides first. You have 3e to the 2x is equal to 7. Divide by 3. E to the 2x is 7/3. Okay, you're going to ln both sides. So you have 2x is equal to ln of 7/3. Then we're going to divide by 2. So you get x is equal to ln of 7/3 divided by 2. And again, that's your exact answer. And if we approximate it, it's 0.5 4, 2, 4. And we can check it on our graphing calculators. And that's the correct answer. Okay, next page. Now let's look at some logarithmic equations to solve. Okay, so very similar to the fact that if your bases are the same, the exponents have to be equal. If your logs are the same, the inside of the log, the 5x minus 1 on number 5, and the 2x plus 17 on the right-hand side are called arguments. So when you have this log base 2 of each side, you have 5x minus 1 is equal to 2x plus 17. Then this takes us back to algebra we're supposed to know. So we're going to move the x's to one side. So we'll move the smaller x. And the numbers to the other. So you get 3x minus 1 equals 17. Plus 1. 3x equals 18. Divide by 3, x equals 6. Now, because logarithms have restricted domains, we have to check our answer. Mainly, we don't want it to be a negative, trying to take log of 0 or log of a negative. So if you plug in 6 on the left side, and you plug in 6 on the right side there, let's see, log base 2 of 2 times 6 plus 17. 30 minus 1 is 29, and here we get 29 also. So you can see that if we check it, we get the same answer. All right, let's solve number 6. You have to have a single log. So log is base 10, so log, subtraction goes to division of 3x minus 4 divided by x plus 1 equals log 2. Then we have the same idea, same concept, that if the logs are equal, the arguments have to be the same. So 3x minus 4 over x plus 1 equals 2. Now I'm going to go ahead and write 2 over 1 and cross multiply. So I get 2 times x plus 1 is equal to 1 times 3x minus 4. Okay, and we can't see that very well, so let me shift that over a little bit. So you have 2 times x plus 1 is equal to 1 times 3x minus 4. So that's 2x plus 2 is equal to 3x minus 4. Again, variables on each side. So subtract 2x from each side. 2 is equal to x minus 4. Add 4. We get 6 equals x. And again, when we check it, when I plug it in, 3 times 6 is 18, minus 4 is 14. So that's a positive. 6 plus 1 is 7. Notice I could type it in the graphing calculator, but just checking again to make sure this argument here, these numbers, when you plug in your answer, are not equal to 0 or a negative number. Okay, number 7 is natural log with base e. So again, single logs. This is ln, addition goes to multiplication, of x plus 3 times x equals ln of 10. So again, the arguments have to be the same. This becomes, okay, x plus 3 times x equals 10. Distribute x squared plus 3x equal 10. So it's a quadratic. X squared plus 3x minus 10 equals 0. And we have the choice of either using a factoring to solve or the quadratic formula. So I'm going to choose to factor because I know 5 times 2 is 10 and 5 minus 2 is going to give us 3. So it's x plus 5 to get a positive 3, x minus 2. And if I FOIL it, x squared minus 2x plus 5x, that gives you your 3x minus 10. So you get x plus 5 equals 0, or x minus 2 equals 0. So you have x equal 2, or x equal negative 5. Now remember, if I go in there and I take ln of negative 5, you can't take logs, no matter the base, can't be a negative. So you get x equal 2. All right, so let's look at this one. Notice this is different. We have a log only on one side. So if you have a log only on one side, you want to write this in exponential form. So it becomes 5 is a base, so 5 to the second equals 3x plus 4. So you get 25 is equal to 3x plus 1, not 3x plus 4. Okay, then we're going to subtract 1. So 24 is equal to 3x. Divide by 3. 8 is equal to x. And again, being positive, I would tell you most of the time your answer will be okay. But let's check. 3 times 8 is 24, plus 1 is 25. So that gives me a positive number, so that's good. Number 9, log x plus 6 base 3 minus log x minus 2 base 3 equals 2. Again, when we're solving our equations involving logarithmic functions, you have to have single logs. So we're going to do division because it's subtraction. Subtraction rewrites as division. Okay, so again, your base is 3 here. Okay, so we're going to rewrite it. 3 to the second equals x plus 6 over x minus 2. Now, the other time I did a proportion to solve. Here, the other option is this. You can multiply each side by the denominator. So in this case, it's x minus 2. So what I'm going to do is I'm going to multiply each side by x minus 2. Now remember, don't distribute with the fraction. These divide out, and I'll distribute. So you get 9x minus 18 equals x plus 6. So we'll subtract x from each side. And we're going to get 8x minus 18 equals 6. Then moving up here to the right, add 18. 8x equal 24. Divide by 8. So x equals 3. Again, make sure when I plug it in, I'm not going to get 0 or negative. 3 plus 6 is 9. That's good. 3 minus 2 is 1. And again, we could use our graphing calculator, but what we really want to watch out for is to have an answer that's not in the domain. Okay, so 10 is tricky. The reason 10 is tricky is because there's a log on each side. So if you recall from algebra, if there's a variable on each side, you had to move your variables to one side. So I'm going to add the log x to both sides. Okay, so a little bit of a challenge here. Log of x plus 15 plus log x equals 2. Okay, again, single log x plus 15 times x equals 2. If you remember, what's the base of log? It's a 10 here. Okay, when you have a single log, we will rewrite it in exponential form. So 10 to the second equals, I'm going to distribute x squared plus 15x. 100 is equal to x squared plus 15x. Subtract 100. So 0 is equal to x squared plus 15x minus 100. And again, I'm going to factor because it's an x squared. So you have x plus 20 times x minus 5. So x plus 20 equals 0. So we're going to get x equal negative 20, which is not going to be part of your answer. X minus 5 equals 0. x equals 5. So there's only one solution, x equals 5. All right, number 11. If $20,000 is invested in an account earning 2.5% interest, compounding continuously, how long will it take for the money to grow to $45,000? So compounded interest continuously is A equals P e to the RT, where A is your final amount. So 45,000 is equal to 20,000 e to the interest. Remember, percent means out of 100, 0.025 t. So you're going to isolate your variable term, which is the e to the 0.025 t. So divide by 20,000. Okay, and I know I'm not being consistent with the commas, but just so you guys can see that, we'll do 0.025 t. So if I use my graphing calculator, we get 2.25. Now I could change it into a fraction. If it's repeating, like you say, for example, if it was like 3.55555 and then a 6, go ahead and do math, enter, or get a fraction for me. You're going to ln both sides because ln is understood base c. That's your natural logarithm. Okay, and recall ln is e, so once again you have 0.025 t is equal to ln of 2.25. You'll divide by 0.025. And if you get a negative number, you're wrong, because we know time has to be positive. And let's see, I made a mistake. I was looking at my calculator. I did not close parentheses. ln of 2.25. Make sure you close parentheses here. Then divided by 0.025. And you get 32.4 years. And the reason I know that is because my units for time are in years. All right, so let's look at this last problem. The following formula relates the energy in joules released by the earthquake of magnitude M. Log E is equal to 5.24 plus 1.44 M, where M is greater than 5. So what is the energy released by a magnitude of 6? The earthquake has magnitude of 6 and a magnitude of 7. So we're going to put M equals 6 first, and it's just straight plugging in. Log E is equal to 5.24 plus 1.44 times 6. So log E is equal to, that's a number. So we're using the calculator to get that numerical value, and you get 13.88. Okay, recall that your base is 10. So E is equal to 10 to the 13.88. And let's see, 10 to the 13.88 is, so E is equal to 7.59 times 10 to the 13 joules. For M equal to 7, again, plug in 7 for the M value. So log E is equal to 5.24 plus 1.44 times 7. Log E is equal to a number. Let's see, and that is 15.32. You understood base is 10. So E is equal to 10 to the 15.32. So E is equal to, we get 2.089. And again, you'll be instructed if it's 2 or 3 decimal places, times 10 to the 15. So just for comparison, okay, A 1 megaton nuclear weapon would have the energy release of, see what that says there, 4.18 times 10 to the 15 joules. And the eruption of the volcano in 1883 produced an energy release of 2.09 times 10 to the 19 joules. So you can see when we're talking about a magnitude for an earthquake, that even though the magnitude is a difference of 1, the actual energy it produces is from a 10 to the 13 to 10 to 15. That's 100 times more. So there we are, how to solve equations involving exponents and logarithms. Have a good day.